Are you John Smith?
I am. I'm here for the gamma ray test.
Great, come in. Dr. Turnbull, nice to meet you.
Nice to meet you.
Hold out your arms.
Okay. Hey! What is that?
This? And here we have tiny particles of technetium. Technetium emits gamma ray particles. We need it for your gamma ray scan.
Okay, but can you tell me a little bit more about it?
Sure. Technetium is located here on the periodic table. It is a very unique element because it was the first element to be made by man.
Okay, can you go more in depth?
Absolutely. As you can see, technetium's atomic number is 43, therefore giving it 43 protons and 43 electrons. Its most common atomic mass is 99, but the average of all its atomic masses, which is 98, is displayed on the periodic table. The atomic mass is the protons and neutrons added together. As you can see here, it has 43 electrons and 43 protons. It also has 55 neutrons. The 43 protons and the 55 neutrons are added together to get the 99, the atomic mass. Other atomic masses would have different numbers of neutrons. I've just shown you different isotopes. An isotope is the different atomic mass in each type of technetium molecule. Now, onto electron shells. In order from the nucleus to the outer shell or the valence shell, it has this many electrons on each shell. 2, 8, 18, 17, and 1 valence electron, which will become important later. Now, since it has 5 electron shells, it is in the 5th row of the periodic table, or the 5th period. Now, since it has only 1 valence electron, you might think it would be in the alkali metals, but it's actually in the transition metals, which either have 0, 1, 2, or 3 valence electrons. Since it has 1 valence electron, that tells us that it is a metal. It is also a solid at room temperature.
Well, that's cool, but how can it bond?
Well, since technetium only has 1 valence electron, we have a lot to work with. The way elements bond ionically is by giving or receiving electrons to either have an empty shell or a full outer shell. Now take chlorine for example. It has 7 valence electrons. What if we try to bond it with technetium? Well, let me show you. As you can see, technetium has 1 valence electron. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. To form ionic bonds, technetium will give away its electron and give it to chlorine. Now, technetium has an empty outer shell and chlorine has a full outer shell. Now, since technetium lost a negative, it is now plus 1. Since chlorine gained a negative, it is now minus 1. And as we all know, through electromagnetic force, opposites attract. So, they will attract and form technetium chloride.
Okay, but what if it tries to bond with oxygen? Oxygen only has 6 valence electrons.
In that case, we'll need 2 valence electrons to fill oxygen's outer shell. So what do? We take 2 atoms of technetium, as I'll demonstrate here, each with 1 valence electron. Now, I will draw oxygen with 6 valence electrons. So what happens now? Both of the technetium atoms give away their valence electrons to oxygen to fill its outer shell. Now, we have 2 technetium atoms positive by 1, and we have 1 oxygen that's negative by 2. 1 plus 1 equals 2. Positive 2 and negative 2. Then they attract to form a bond. Now we have technetium oxide.
What about the chemical formulas?
Well, for the chlorine bond, the symbols will be T, C, C, L, because we have 1 atom of technetium and 1 atom of chlorine. Now, for the technetium oxide bond, it's a little bit trickier. We have T, C, subscript 2. Oh, since we had 2 technetium atoms and 1 oxygen atom.
What about noble gases?
No, because noble gases already have 8 valence electrons.
What has this element done for our society?
I'm glad you asked. It was discovered in 1937. However, the creator of the periodic table, Dmitri Mendeleev, predicted that an element would be in its place, so he gave it the name of alkyl-manganese, or EM. When discovered, it made huge contributions to science and nuclear medicine.
Alright, well, thank you for your time.
Pleasure to meet you.
Thank God I got out of there before I got a shot.